Okay, questions before we get started. So today I'm going to go over 2D. The calendar says that we're supposed to do 2D and which calendar? That calendar, 2D and 2E today. I'm probably not going to get into 2E because 2D is pretty big. So I'm going to do 2E tomorrow. So tomorrow is a real teaching day. Again, if you're not able to make it, that's fine. You can watch the recording. But that also means that you'll have to spend 50 minutes in the FMC or somewhere getting additional support, okay? So 2D, all sorts of fun. First thing we start with is currency conversions. This is what, page 41, I think, in your notebook? So these are as of 2019. I haven't updated the currency conversions since then. So they're 2 years old, but they're still pretty current. How do you read this? So you have two columns, dollars per foreign and foreign per dollar. How do you know when to use what? So the first column is when you're starting at foreign and you want to go to US. The second column is in you're starting at US and you want to convert to foreign. And again, dollars per foreign is going to be $1 US for blank foreign currency. Or it's not $1 US, excuse me. It's going to be the US money for one foreign. Versus foreign, you've got your money foreign to $1 US. Okay. How do we use that? So it says convert. So how many pesos can you buy with $100? So we want pesos, which is a foreign amount, and we're starting with US money. So we're taking 100 US, and we want to go to a foreign amount. And in this case, we're looking at the peso. So because we're starting with US and we're going to foreign, when we look at that table above, we're going to be dealing with that second column, okay? So we want the peso, which is right here, 18.9157 pesos per US dollar. So again, how do we think about this? 18.9157 pesos to $1 US. So if we set up our conversion, we're going to take 100 US. We're going to multiply it by 18.9157 pesos to that $1 US. And again, remember, we're always trying to have our unit of measure. We're trying to cancel diagonal from each other, right? So you see 100 in the upper of the first fraction and $1 in the lower of the second fraction. So when we multiply, we cancel the dollar portion and we have 100 times 18.9157, which gives us 1,891.57 pesos. So if you don't get too caught up in the types of money that we're using. This is literally just straightforward conversions like we were doing from American to metric or metric to American, right? It's the same idea. So in number 2, we want to go from British pounds to US dollars. So that means we're starting at foreign and we're going to US. So seeing that we want to do that, do we want to use column 1 or column 2? 1, yeah, because the first column is our foreign to US. So we've got 60 British pounds, and I'm just doing BP because there's no way I can make that funny little symbol that is the British pound. And then if we look in here, British pounds, we have 1.29081 US dollars. To 1 British pound. And when we multiply those together, rounding to the nearest penny because it's American money, we end up with something. We get 77.4486. The currency counter is only going to give you to the nearest pound because that's how accurate our money is. So they'll give you 77.45. I'm assuming maybe they might round down. I'm not sure. I haven't had to convert currency in a really long time. But for our purposes, we'll round up. We'll give some money away, right? Why not? So trying to zoom out. So I want you to look at number 3. We're converting 31,000 yen to US dollars. So again, we're starting with foreign money and we want to convert it to US money. So I want you to do that one on your own. Send me your answer in a chat. Luke, that's a good question about My Math Lab. They're going to give you a table and you're going to use those conversion amounts that they give you in the table. Because like in your homework, there are currency conversions. So like number 17 in your homework, it gives you the 2 numbers and you have to choose which number to use. So what I'm saying is like it's giving you like the row that I have on there. And you'll have to use, do you use the dollars per foreign or the foreign per dollar? And that's it. But you would use those and not mine. So the bounce that are rolling in thus far, you guys are doing great. So those are correct. If you've entered an answer, your answer is correct. So we've got 31,000 yen, which means we're going to want 1 yen in the denominator, right? We're canceling yens. So that means we're dealing with the first column, which is dollars per foreign. The yen is going to be 0.00896 US dollars per 1 yen. When we multiply those together, we end up with approximately $277.76. So if you were thinking about going to Japan and you were looking up, hotel prices, at first it would seem astronomical because they will list them in yen and you're like, oh my God, 31,000 yen. I can't pay that for one night. And then you're like, oh, it's 277 US dollars, which is still like an expensive hotel, right? But still, it's all about the conversion, right? Okay, so number 4, we want to convert $450 to euros. So again, think about it. I'm starting with US and I'm going to foreign. So you need me to show you, think about which column you want to use and go from there. Answer so far correct? Okay, so again, because I'm starting with US and I'm going to foreign, I want to cancel out my foreign, right? Which means we want to choose from the, I want to cancel out the US, which means I want to choose from column 2. Okay, because it says per dollar, which means my US is in the denominator, and that's where I want to choose from. So I have $450. And I want to multiply by the column that's going to give me the per dollar amount. Because again, I'm canceling dollars. So the euro is going to be 0.89661 euros, which is a weird like sideways E. It's a little more curved E. Multiplying those two together, I end up with 403.47 E. Or euros. So again, the best way that I know how to give you the idea to be consistent is you use column 1 where you're starting from foreign and you're converting to US, or you use column 2 when you're starting with US and you're going to foreign. And the reason I know that is because think about what you're trying to cancel. Remember, this word per means division, right? So it's showing if I want to cancel foreign, I need to use the column that has foreign in the denominator. Or if I want to cancel US, I need to use the column that has US as the denominator. Okay, so the next page says convert 350 to Canadian dollars. So unfortunately, you got to go back and forth. So go ahead and send me your answer for that one. You just put your answer in, you're all correct.
Would it be dollars per foreign or foreign per dollar?
Foreign per dollar, because we're trying to get rid of dollars, so we want dollar in the denominator. Okay, so I want to convert 350 to Canadian dollars. So I've got 350 in US bucks on top, which means I need $1 in US on the bottom. So if I want $1 on the bottom, I want to do per dollar, which means I want to use the 1.34534, right? We're using the second column. When I multiply those together, I end up with 470.87 Canadian. So you always want to think about, what am I canceling out, right? And whatever you're canceling out is what you need to make sure is in the denominator. And again, the per is meaning division. So look at what value comes after per. If that's what you're trying to cancel out, that's the column you want to choose. Okay. If you had chosen column 1, you would have been taking US times US over Canadian, and that's not going to cancel out what you're trying to get rid of. So number 1 uses this information plus our going back to converting between metric and American systems. So this is a gas station in Canada sells gasoline for Canadian 1.35 per liter. So we have 1.34 Canadian to 1 liter of gas, right? And it says, what is the price in dollars per gallon? So we're trying to go from Canadian to US and from liters to gallons. So if we think about our first conversion factor, let's get rid of the Canadian amount, which means we're going to have 1 Canadian in the denominator here, which going up and looking at our table, we're going to use the first column because that's US dollars per foreign. So we'll do 0.74301. We have, so it's 70, at this time, it was 75 cents-ish per Canadian dollar, right? And now we need to think about, what do we need to get rid of, right? We need to get rid of liters and we want gallons. So the unit conversion here is going to be 3.785 liters to 1 gallon. Remember, this is coming from our conversion sheets. Let me pull that up really fast. So remember, in our conversion sheet, we have a metric unit and we want to convert to a Canadian unit, which is why we're choosing something from this column. But our liters are on the bottom. So that's why we have 1 gallon here. If we had chosen this column, we would have put 1 liter in the numerator and 0.2642 gallons in the denominator, okay? So you could have used either of these conversions. I just chose the one that would give me the 1 in the denominator, that's all. So we can see as we move through this, our Canadians will cancel. And then our liters will cancel. And the nice thing about choosing the conversion factor that gives us the 1 in the denominator is now I just have 1s all the way across when I multiply. And so what we end up with is, let's see, 1.34 times 0.74301 times 3.75. Oh, cool. Thing wasn't even on. Now, is the gas station going to list out their price that long? 3.76847, blah, 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 blah. No, they're going to go to the nearest penny. Well, actually, they go to the nearest thousandth of a penny because they always put like a 9, whatever.
I've seen most gas stations, they go like over to three decimals.
Right. So they would do 3.768 hundredths, something like that is how they write it. We're not going to be crazy like that. Let's just round our answer off, because how many are you really paying attention? In your mind, you're like, Aaron, it's 3.77 a gallon, which, oh my God, I do not want to see those prices again, right? Those are early 2000s prices. We don't want to see those anymore. But I will admit, so I haven't been in Canada for a while. The last time I was in Canada, I think, was summer of 2016. And even understanding the whole conversion and everything like that, did I actually stop to do the conversion while I was sitting at the gas station figuring out how much it was going to cost me? No, I just blindly paid it. I was like, whatever, I'll get the bill when I get home. But this is what happens with your, for your credit card, all they're looking is the total monetary amount, and then they're putting that in. So, anywho's. So questions about that gas conversion, or any more monetary conversions. So we're going to switch gears from this point and deal with other types of unit conversions. But I don't want to move on from money conversions if there's any more questions about it. Okay. So, Flathead Electric, they charge, in this fictional situation, 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt light bulb on for a week, right? So you go away, you leave your outdoor light on to scare off the honest burglars. Not that anybody who's driven past more nights in a row and seen that it's on every night is going to, know that you're not gone. But we do it to make ourselves feel safe, right? How much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light for only 25 watts of power? So, first of all, things to know. A 100, I don't want to write in red, that's an angry color. So, a 100-watt bulb, what does that mean? That means that we're using 100 watts per hour. They don't tell you that when you're buying light bulbs, but that's what that means. Okay. So let's think about a week. First of all, we've got our 100-watt bulb, and we need to convert that amount to kilowatts. So because the reason we're converting to kilowatts is because Flathead Electric goes, I don't care about your puny watts, we want kilowatts, right? So remember, 1 kilowatt is 1,000 watts. Kilo means 1,000. So that's going to give us, what is that? 100 over 1,000. 0.1 kilowatts in 1 hour, right? That's what we're using in our little thing. Okay, so how much power is that for a week? So what do we got to do? We know that we're doing 0.1 kilowatts per hour. How do we get that out to a week? Well, how many hours are in a day? Right? There's 24 hours. Okay, and then what do we got to think of? We got to go, okay, great. So we got We got 24 hours in a day. We got 7 days in a week. We got to go with that business, right? So if I have 0.1 kilowatts in 1 hour, and we're going to go with, okay, there's 24 hours in 1 day, and there's 7 days in 1 week, right? This is how we're getting, okay, we already know how many kilowatts we have. How much are we using over the course of the whole week? And if it's hard for you to think about in terms of these fractions, right? Think about them in terms of just, okay, I know I have this much for an hour, so I got to multiply that amount by 24 to see how much I use in the whole day. And then I know that there's 7 days, which is where we end up multiplying by 7. So 0.1 times 24 times 7 gives us 16.8 kilowatt hours really, in 1 week. So that's how much energy that one bulb uses over the course of the week. So then what's the cost? Well, we take our total energy used and we're going to multiply it by the rate. They're telling us it's going to cost 15 cents per kilowatt hour. Which gives us a whopping $2.52 for 1 week. Which I'm sure you're like, so what, Aaron? It's $2, $2.50 I spent to keep this bad boy on. Okay. But how would we figure out the savings for a year? So first of all, how much does it cost to keep it on for a week? We've answered that question, right? The first question was how much does it cost right here? All right. $2.52 for a week. And the question is how much, the second question is how much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light, but for only 25 watts of power?
Would you have to find out how many weeks in a year?
Yes, and I can tell you that. I'll be nice. There's 52 weeks in a year. So you might be tempted to go back and instead of doing the 100, put a 25 in, okay? But think about this. What portion of 100 is 25?
Wait, what were you asking again?
So I'm just putting this question out there. Thinking about switching from a 100-watt bulb to a 25-watt bulb, right? What portion of 100 is 25? Like fractionally speaking.
1/4.
140, okay. So we could do the big, it's 1/4, right? 25 is 1/4 of the amount. So if I take 252 and I times it by 52, we know that it's going to cost us $131 for the year. Okay. But if I switch to the lower watt bulb, it's going to be 1/4 of the power. So 16.8 divided by 4 is going to give us 4.2 kilowatt hours. And if I multiply that by 0.15 times 52, it's only going to cost us $32.76 for the year. So then the savings, since I'm running out of room, do it off in this little box on the side. The savings is going to be 131.04 minus 32.76, giving us $98.28. So just switching, you're going to save almost $100 a year, which that adds up, right? Over the course, if you decide you have to leave it on, all the time, right? Was there other ways we could have done this problem? Did anybody think about it a different way? Taylor, you want to share out how you thought of it?
I just took the price or the cost for the week and divided that by 4 and then times that by 52. And it gave me the same answer instead of doing the 16.8 kilowatts per hour per week.
That would have been fine.
Okay.
You
cool.
could have also taken 2. Let's see, 2.52 times 0.75. So you could have taken the 252 and multiplied it by 0.75 because we're saving 3/4 of that amount and multiplied it by 52, and you would have gotten to 98.28 as well. It's another way of thinking it. Taylor, the way you described it, I personally in my shorthand, I did do that, just divided it by 4 and went that way. I wanted to show that the kilowatts were actually smaller too. That's why I divided the total power by 4. That's all. But so what I'm trying to say is there's multiple ways to think about this, right? It's just because you don't like the way that I do it, you get to the right answer and your math is sound, then we're good. If you do some fancy math that's not really math and you somehow still come up with the same answer, then we got to talk about it. But those are all valid ways to think about it. So on the next page, we're drugging kids. We got to deal with medical dosaging. So number 3 says the child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dose based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. How much amoxicillin should the child be prescribed every 12 hours? So first of all, ignore the kid's weight. Let's think about the dosage. The dosage is 30 milligrams per kilogram per day. I don't know why I'm writing. And we're dividing the dose into 12 hours. So how many doses are we giving in a day? 2 doses, right? So that means we're going to take 30 and divide it by 2, giving us 15 milligrams per kilogram per 12 hours. Because again, I'm just taking the whole day, which is 24 hours, dividing it by half. So I'm dividing how many milligrams they're getting in each time. And the reason why we have to divide it by half is because their total over the course of the day has to reach that 30, which means we can only get 15 at the beginning and 15 at the second one. So now how much should they be prescribed every 12 hours? Well, we know the kid weighs 15 kilograms. And we know that the dosaging says we're taking 15 milligrams per kilogram per 12 hours. So we have 15 times 15. We can see here, because I have kilograms in the numerator and kilograms in the denominator, those cancel. 15 times 15 is going to give me 225 milligrams per 12 hours. So if the medication is to be taken in a liquid suspension with a concentration of 25 milligrams per milliliter, that's a really fancy way of saying the pharmacist gave the parents the bottle of the liquid, right? It's like that pink liquid or whatever. They have all the different flavors, right? And they're just saying, okay, the concentration of this is that for every milliliter in this bottle, there's 25 milligrams of the drug. So how much should the child take every 12 hours? Well, we're going to take what we're giving them, 225 milligrams over 12 hours. And then we need to think about, how do we write that second fraction? Because 25 milligrams per milliliter means 25 milligrams per 1 milliliter, or it can also mean 1 milliliter for 25 milligrams. Both are true. It's just about which one do we want to choose. Do we want to choose the first fraction, or do we want to choose the second fraction? This is kind of going back to the idea of what we were dealing with the currency conversions. When deciding, we're always thinking about what is the unit of measure we want to cancel. So at home, the mom or dad or whoever is giving the kid the medicine is going to have the little cup. And on the little cup, they're going to have milliliter marks, right? Which means they are going to be measuring out this drug in milliliters, which means we need to cancel the milligrams. So I'm going to use the second fraction, putting 1 milliliter over 25 milligrams. 225 divided by 25 gives me 9 milliliters per 12 hours. So again, we're always asking ourselves, what am I trying to get rid of? And whatever I'm trying to get rid of is what needs to go in the bottom. So your homework, is it your homework? Yes, number 8 in your homework is very similar to this. Okay, in number 8 in your homework, there's a first part that asks you to give the amount in tabs. And then the second part of the answer is give the amount that you're administering in milliliters. My hint to you when you do this problem is to answer part B, go back to the total number of milligrams that you're given. Don't try to convert using the number of tabs as your answer in part A. If you write that down and then you go to do your homework and you look at number 8, what I'm saying is going to make sense, but right now I understand that it doesn't make sense. So again, for number 8 on your homework, and let's just make sure I'm really telling you it's number 8 and I'm not lying to you and you get in there and you're like, here it was number 10. Yes. Okay, hold on. Let me share this with you so you actually understand what I'm talking about. Okay. So number 10 says certain antihistamine is often prescribed for allergies. The typical dose for a 100-pound person is 25 milligrams every 6 hours. So the first part says, following this dosage, how many 12.3 milligram tablets would you take in a week? So to even answer part A, you have to come up with the total number of milligrams that the child is going to take over the course of the week. And then you'll convert that to tablets. When you go to part B, when it then has you convert to the liquid suspension, go back and use the total amount of milligrams that you found. Don't try to cut through by using the number of tablets, okay? That's what I'm trying to say to you. That's what I mean. It'll make more sense when you're doing the problem, I promise. But that's my hint. And again, it's very similar to what we just did. Okay. Let's go back to our notebook page. Oh, big problem. A doctor orders 2.3 grams of Rocephin to be given by a 15-pound, to be taken, infant's not giving the drug, we're taking the drug, to be taken by a 15-pound, 6-ounce infant every 8 hours. The recommended dosage is 15 to 100 milligrams per kilogram per day. Is the ordered amount within the recommended range? So before we start this problem, I want you to think about the things that don't match in it, meaning I want you to think about what do we need to convert here, right? What's stuff that clearly we got to go from one thing to another? So maybe on the side of your paper, list off what you think we might need to convert. So just having everybody think about it for a hot minute before we jump in. And then after you think about it, I want you to send me a direct message with the stuff that you think we might need to be converting. So there's a lot going on here, right? So when I look at this, I see really 4 conversions we're doing here. Just within the baby's weight, we have to go from ounces to pounds, and then we have to go pounds to kilograms, right? because right now the baby's weight is being given in ounces and pounds. We need to have one whole amount for that. And no, it's not 15.6, right? 6 ounces is 6 out of 16, right? And then we also have to think about, okay, well, we need to go from milligrams of drug to grams of drug. And then the last part is, it's telling us to go from hours. Oh, right. Thanks, Robert. Yeah, from grams to milligrams. There's, we're working between those two. And also we have to go from hours to days. So let's break down the baby's weight too first. So our first is going to be converting. We're going to convert the weight. So we're going to take ounces to pounds. So we know that 1 pound is equal to 16 ounces. So we're going to take 6 ounces. So 6 divided by 16 is going to give us 0.375 pounds. So 15 pounds, 6 ounces is really 15.375 pounds. Tiny little baby, right? What is that, like a 1-month-old, maybe 2-month-old? I don't know. They're little. It's all about like how tired are your arm after a little while holding them. So now we need to go from pounds to kilograms. So we'll take 15.375 pounds. And we're going to use the conversion that, let's be consistent, Erin. 0.4536 kilograms to 1 pound. It's okay if you did 1 kilogram and 2.2 pounds on the bottom instead. I'm just trying to be consistent in keeping my ones. So 15.375 times 0.4536. We get 6.9741 kilograms. I am not going to round. Do not intermittently round. The reason for that is that it will throw us off, because they're going to be doing the problem as if they're not rounding midway. So we finally have our child's weight in kilograms. So now we need to convert the grams to milligrams. So the order is that we have 2.3 grams every 8 hours. Therefore, we know that there's 1,000 milligrams to 1 gram, which gives us 2,300 milligrams per 8 hours. And now we're going to convert the hours to days. We know that then 1 day, hold on, Erin, put these in the right order, 24 hours on the top, because again, we're always asking ourselves, we want to cancel a unit of measure. So where does it need to go? It needs to go diagonal from the starting one. So 2,300 over 8 times 24 over 1. We can think 8 goes into itself once, 8 goes into 24 3 times, giving us 6,900 milligrams per day. I have a bad feeling about this. So the last part says, is the ordered amount within the recommended dosage? So remember, the recommended dosage is we're taking our milligrams per kilograms. I used up a lot of my space here. So I'm going to do 6,900 milligrams divided by our 6.9741 kilograms, giving 989.37 milligrams per kilogram per day. And is that within our range? Uh-oh. We've got a problem here. That's not good, right? Clearly our doctor was off by a power of 10. Like if we just move our decimal place once, oh sweet, we're right in there. Which is why the nurse checks the doctor and the pharmacy checks the nurse, right? Like there's all these checks and balances to make sure that we're not killing babies. So for any of those going on from this class to 140, this is a nice taste of the type of problems you'll be doing in there, or in other nursing classes for that matter. Some questions about that. There's a lot of steps. So that's what, when thinking about these problems, like I said, think about what are the things I have to convert, right? So knowing that I have to go from pounds to kilograms, knowing I have to go from grams to milligrams, knowing I have to go from days, from hours to days, that kind of sets up the structure of my problem of how I need to think about it. So starting with that is really going to help you to figure out what steps you need to go through. Because at first, I get it. This is a big problem. You're like, how do I even start? But just looking at the inconsistencies in the units of measure will give you an idea of where you need to go. So we still have 15 minutes left and we have a choice. You get to tell me either A, we be done for the day and I do all of 2E tomorrow, or we do 2E for 20 minutes and then we just finish it tomorrow. Your choice. My suggestion, because 2E is pretty vague, is that we start it today, but you all decide. Okay. So let me stop sharing for a hot minute. You vote go, like you go home, Robert? No, you want to go for it? Keep going into 2E? All right, let's do that. So give me a hot minute to upload this. Play elevator music in the meantime, something to entertain yourself. So now we're completely changing gears, and it's going to feel at first like these are not related to each other, but they really are. It just takes a while for this all to come together. So we're now going to be looking at percents. So percent means parts per hundred. We have the idea of converting between fraction, percents, and decimals. So if we're going to convert from a percent to a fraction, you put the percent number over 100 and you drop your percent symbol. Obviously, reduce your fraction if you can. If you're going to convert from a fraction to a percent, you first divide the numerator by the denominator to convert that fraction to a decimal, and then you move your decimal 2 times, which is the same as multiplying by 100. The students often forget that's why you're moving your decimal place. To convert a percent to a decimal, you're going to move your decimal point 2 spaces to the left and drop your percent symbol. To change a decimal to a percent, you move it 2 spaces to the right and you add a percent symbol. So I'm going to not go over the absolute change and relative change. We'll come back to those. Let's just focus on the problems that we have first. So the first question is 15 is what percent of 50? So there's 2 ways we can think of this. We can think of it as being 15 over 50, which if we divide that, we get 0.3, which following those steps, if we have a fraction, we convert it to a decimal, we move our decimal place 2 spaces to the left, or to the right, excuse me, we add a percent symbol. The other way we can think of it is if we write an equation out. 15 is what percent of 50? The only thing that changes is that we still end up with writing this as a fraction, right? It's just showing that we're getting that percent number, and we still are going to end up with 30%. So when doing these, something that's helpful to keep in mind is that the part is equal to the percent number times the whole. Or we can also think of this as the percent over 100 is equal to the part over the whole. So when I look at number 2, 162.5% of what number is 286? So we have 162.5% out of 100. The part here is 286. The whole, we don't know. The other way to think of this either of those setups are going to work, okay? 286 is equal to 1.625 times some amount. Either way, what do we get? I want you to solve for X. Either solving the purple problem or solving the blue problem. Doesn't matter. Both are going to give us the same answer. So if you're solving the problem in the purple way, you would have 162.5 times X equals 100 times 286. That can be more confusing, right? If I take 286 and I divide it by 1.625, I get 176 is my answer. They're both going to give you the same answer. It's just making sure that you're doing the steps in the right order. So Laura notes that 20% of her class is absent. If the class has 45 students, how many students are absent? So 20% of the 45 are absent. So we can say 0.2 times 45 equals X. So 9 students. Because 0.2 times 45 is 9. I want you to try number 4 on your own. Mike answered 90% of the questions on his math test correctly. If Mike had 27 correct answers, how many questions were on the test? Okay, so 90% or 0.9 of some amount equals 27. So we're going to divide both sides by 0.9, and that's going to give us 30. If that first step of taking the percent number and writing it as a decimal number is confusing, we can solve it as a proportion. It says 90 out of 100 equals 27 out of X. So X times 90 gives us 90X. 100 times 27 is 2,700. Divide both sides by 90, and we will still get an answer of 30. How are these two related? Well, if I look at the left-hand side, 90 over 100 gives me 0.9, right? If I multiply across by X, I have the 0.9X equals 27. So we're just doing a few steps in our head and then solving from there. So if you're gonna write it out as just a straight equation, you have to convert that percent number into a decimal number. Either way, we come up with 30. Okay, so number 5 says during a 6-month period, Xerox stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? So this, we're going to go back up to our little box of information. So we have absolute. The absolute change is how much did it overall change by? So you'll notice we take the new value and they say minus the reference value. And what I want you to think about this is the end minus the start. Because sometimes the absolute change is negative, okay? So for us, in our thing here, our absolute change is it ended at 14 and it started at 7. So it changed by $7, right? What is the relative change? And the relative change has to do with a percentage. So you'll see that the relative change is the size of the absolute change in comparison to the reference value and can be expressed as a percentage. You'll see this new value minus the reference value. This whole thing is just the absolute change. So you see we're taking the absolute change, dividing it by the starting value, and timesing it by 100%. So what does that look like in terms of our thing? So the relative change is going to be the change in the overall divided by the starting amount, and then times 100. So 14 minus 7 is 7. 7 divided by 7 is 1. Times 100 shows that it increased by 100%. So we had a 100% increase in the price of the stock. So sometimes when they talk about stocks that way, it can be, or anything else that grows by a percent, it can be confusing because you're like, well, it doubled. So why didn't it increase? Like, why isn't it 200% increase? Well, it doubled, so it increased by the measure of itself. So that's a 100% increase. Okay, so if we go to the next page, we're going to continue with these absolute changes and relative changes. So remember, the absolute is the ending minus the starting value. And then the relative change is the absolute change dividing by the starting amount times 100. In terms of thinking about how do these two relate to each other. So the estimated world population was 2.7 billion in 1953 and 7.1 billion in 2013. Describe the absolute change and the relative change of the world population over this 60-year period. So the absolute change is just the subtraction. That's all we're doing. How many people did we increase by? Well, we have 7.1 billion minus 2.7 billion. Don't worry about converting it to billions or like actually adding all the zeros because we're already dealing in billions here. So 7.1 minus 2.7. is going to give us 4.4 billion. So increase by 4.4 billion over 60 years. The relative change is that difference, 7.1 minus 2.7, as compared to the starting amount, 2.7 billion. You'll notice the absolute change is not a percent answer. The relative change is a percent answer. So we have to make sure we multiply by 100. So that means we have 4.4 over 2.7 times 100. Because again, 7.1 minus 2.7 is 4.4. We times by 100. Do not round your answer until you've converted it to a percent. That was a mistake that was made on the exam in that section what had to do with the grades, and they were asking what the percent of at each time was. Is this ringing any bells, right? You had to add up the grades as you went along and find the percent of the amount. And it was having you would find a decimal and then would convert to a percent. Is ringing any bells to anybody? Maybe, maybe not. Okay, so again, don't round until you get to that percent, because when I divide this as a fraction, we get 1.62962,963. We're going to multiply by 100 and we get 162.962963%. Your homework will tell you how many places to round to. If they say to round to the nearest 10th, that means that we would be rounding the 6 to the 9. The 9 then gets rounded up, and we would have to report this as 163.0%. That's rounding to the nearest 10th. We need to add the 0 part in there because we're indicating we have rounded our answer to that decimal point. Okay. World population increased a lot over 60 years. So we'll do number 7 and then we'll be done. So number 7 says the average pay for full-time wage earners varies from state to state. Data from 2009, which was released in 2013, shows that New York ranked first in average pay at $60,300 per person. And South Dakota ranked last at $32,800 per person. Compare the average pay in South Dakota to that in New York, both in absolute and relative values. So what I want is we're going to let South Dakota be your starting amount. So we're going to represent the difference in reference to South Dakota. So I'm going to let you think about that. I'm going to let you do the absolute change and the relative change on your own. So at 3:15, so if you have to go, I understand. Just giving everybody a few more minutes to think about these. Since I'm saying South Dakota is the starting amount, that means we're taking New York and subtracting South Dakota from it, right? When we think about absolute value, you have your ending value minus your starting value. So our absolute change is going to be the 60,300 minus our 32,800, which gives us an absolute change of $27,500. The relative change is that 27,500 over our starting amount, 32,800. Then remember, we have to multiply by 100. Can't forget that step, because we want a percent. So we're going to get 83.84%. So what does that mean? That means that New York, to get to the New York pay, it's an 83.8% increase on top of the South Dakota pay, which to read the other way means that New York is 183% the South Dakota pay. Though we're going to talk about in 2E, how is that relative to the cost of living? And it would be, is it relative to what the cost of living increase is for if we were to adjust? So sure, the pay is bigger, but then it might not actually be appropriate for what the cost of living is. And so sort of how all of this is going to come together. We'll look at that later. That's in 2F, that we look at cost of living and things like that. Not 2E, because we're in 2E. But we are done, okay? I'm going to let us be done. We did a lot today. We're going to finish this up tomorrow. Hopefully it won't take the full 50 minutes tomorrow.